Alright, hey everybody, you wanted a video and here you go. Alright, we did these problems in class, so I'm probably just going to get through them quickly, but hopefully with enough information to get you to understand. Alright, number one, to simplify. So our main goal when we simplify is to make sure that we get it to a point where we cannot do anything else to the problem. So if you remember in class, we took the secant and we changed that to 1 over cosine. We changed the tangent to sine over cosine. And we kept sine the same. Now, what you should do next is multiply. 1 times sine is equal to sine. Cosine times cosine is cosine squared. All over sine. Now we've got some fraction things going on. It's double fractions. So I want to change this fraction bar to multiplication. And I want to write the reciprocal of sine, which is really 1 over sine. Now I'm going to multiply that by this sine over cosine. If you notice that sine's on top, sine's on bottom, so I can cancel them out. And I will be left with 1 over cosine squared. Now that's not our final answer because this is a reciprocal. So 1 over cosine is actually equal to secant. Always box your answers when you're done because that tells me that you're completely done. Alright, this right here, tangent squared plus 1. Remember in class I said you cannot cross these out and say that it's equal to 1. That's mathematically incorrect. And the reason why it's incorrect is because that this tangent here is attached to plus 1. So you can't do that. But what you should notice is that tangent plus 1 is an identity. It's one of your Pythagorean trig identities. So tangent squared plus 1 is actually equal to secant squared. So we're left with tangent squared on the bottom. And now we can simplify this. Secant becomes 1 over cosine. Tangent becomes sine squared over cosine squared. Now this is also an identity. It's secant squared minus 1, but it really won't do anything to the problem if you change that to the identity. So it's easier just to change it to what we call the quotient identity. So now we're going to do the same thing here that we did up here. We're going to change this fraction bar here to multiplication. And we're going to do the reciprocal of sine over cosine, sine squared over cosine squared. If you noticed, you have a cosine here and a cosine there, so you can cancel them out. And you're left with 1 over sine squared, which is cosecant squared. Okay, so remember our goal with simplifying is to make sure that we get it down to where it can't be broken down anymore. Alright, so now we have to find the exact value for sine of 255. In class today we came up with a lot of different choices. We had 210 plus 45. These are all numbers from the unit circle. 225 plus 30. 300 minus 45. So there's a lot of different things that you can choose to do. So you don't necessarily have to do, you know, 210 plus 45. I'm sure there's other ones that you can do instead that will give you the same answer. So, you know, whatever you're comfortable with. Alright, so I'm going to break down all 3 of them for you just so you can see how we can get the same answers from 3 different things. So if I break this down according to the expansion in the box at the top of your paper, this becomes sine of 210 cosine of 45 plus, remember with sine it's plus and plus, cosine of 210 and sine of 45. Knowing on your unit circle that 210 is in the third quadrant, so sine and cosine are going to be negative. So this is negative a half, and this is negative square root of 3 over 2. Cosine of 45 and sine of 45 are the exact same thing, square root of 2 over 2. Now, you are allowed to multiply radicals that are not alike, you just can't add them. So negative 1 times radical 2 is negative radical 2. 2 times 2 is 4. Negative radical 3 times radical 2 is a negative radical 6. So your final answer will be negative radical 2 minus radical 6 over 4. So that's if we had used 210 and 45. Now, what if we used 225 and 30? So it'd be sine of 225 times the cosine of 30 plus the cosine of 225, I'm going to run out of room, times the sine of 30. Okay, so when you break that down using the unit circle, the sine of 225 is negative square root of 2 over 2. And so is the cosine of 225. Because remember, the third quadrant, everything's negative except for tangent. Okay, the cosine of 30 is square root of 3 over 2. And the sine of 30 is 1/2. Okay, negative 2 times 3 is negative square root of 6 over 4. Negative 2 times 1 is negative square root of 2 over 4. So when you put them together, this is what you get. Basically the same thing. Okay, a negative square root of 2, negative 6, negative square root of 6, negative 2, same thing. Okay, last one that I'm going to expand just to show you that you can get the same answer for 3 different things is sine of 300 minus 45. So that expansion becomes sine of 300 times the cosine of 45 minus the cosine of 300 times the sine of 45. Now, 300's in the fourth quadrant, so everything is negative in the fourth quadrant except for cosine. So cosine of 300 will be 1/2. Sine of 300 is negative square root of 3 over 2. Then the cosine of 45 is square root of 2 over 2. And the sine of 45 is positive square root of 2 over 2. So when you multiply, you get negative square root of 6 over 4 minus square root of 2 over 4, which gives us the exact same thing that we had for 225 plus 30. So basically, it does not matter what numbers you choose as long as the numbers you choose are in the unit circle, because the unit circle is the only values that are exact values. And remember, exact value is always a fraction or a radical. It's never a decimal. Okay, because decimals are approximations. All right, on to number 4. Okay, number 4 says find the value of sine of a minus b if cosine of a is equal to 8 over 17 and sine of b is 5 over 13. This is your triples. Okay, so I think there's 7 triples that I need you to know. 3, 4, 5, 5, 12, 13, 8, 15, 17, 9, 40, 41, 12, 35, 37. Oh, I'm missing 2. 7, 24, 25, And there's one more obvious one that I'm probably missing, but you should know these 6. These are the 6 basic ones that we use on tests. So if the cosine of A is 8 over 17, you must know the sign, because the expansion for sine of A minus B is sine of A times the cosine of B minus the cosine of A times the sine of B. Well, right now, just fix this. Right now, we have the cosine of A. So we have this value and we have this value. So we're missing these two. And in order to get those two, you have to use your triples. So if cosine is 8 over 17, and we know our triples mean that cosine is adjacent over hypotenuse, looking at our triples, we know that this must be 15. So that means that the sine of A must be equal to 15 over 17. Now here, the sine of B is 5 over 13, so it's opposite over hypotenuse. So knowing our triples, we know that this has to be 12. So cosine of B is 12 over 13. So now we have these two values. So we're just going to plug them in. Sine of A is 15 over 17. Notice I didn't put any sine or cosine in my answer. Cosine of B is 12 over 13 minus, now I use these two answers, 8 over 17 and 5 over 13. Okay, so now I just multiply them out. You can put the whole entire thing in your calculator if you want. Just make sure that you keep things in parentheses. So this is 180 over 221. This is 40 over 221, which equals 140 over 221. Now you can skip this step and go right to this step. Just make sure to get this answer, you use math enter. Okay. All right, the next one says if cosine of theta equals 3 over 5 and theta is between 0 and 90 degrees, find the exact value of sine of 2 theta. So I know that looking at my triples, cosine would be 3 adjacent over hypotenuse. So that means that I do need the value for sine. So sine is 4 over 5. The expansion for my double angle, if I look at the top of the paper, is 2 sine theta cosine theta. Well, I know what sine theta is, it's 4/5. And I know what cosine theta is, it's 3/5. So now using your calculator, you can just multiply across, and you wind up getting 24 over 25. So you will be needing to use these triples for your half angles, for your double angles and for your sum and differences. All right, now to the back. All right, so it says that if sine of theta is 12 over 37 and x is in between 0 and pi over 2, find the exact value of sine of 2 theta and tangent of 2 theta. So before we do anything, we do need to look at our triangle to figure out what tangent and cosine is so that we can figure out the answer to these problems. So sine is opposite over adjacent, and since this is a triple, I know that that's 35. So that means that cosine is 35 over 37, and tangent is opposite over adjacent, so it's 12 over 35. So looking at the top of the paper, so you have to turn your paper around and look at the top, the expansion for sine of 2 theta is 2 sine theta cosine theta. Sine theta is 12 over 37. And cosine theta is 35 over 37. So now just multiply everything out and you'll get your answer. Make sure you put math enter in your calculator so it'll allow you to get your answer. Get into the habit of boxing your answers. It just makes it a lot easier for me to find on your paper. Alright, tangent is a little different. Turn your paper over and look at the expansion for tangent. You'll notice that the expansion for tangent is to double tangent on the numerator, and in denominator you have to subtract by the square of tangent. So that's going to be 2 times 12 over 35 all over 1 minus 12 over 35 squared. Now when you put this in your calculator, just make sure that you use double parentheses. So put parentheses around here in your calculator, then press divided by and put parentheses around here. Because that's the only way that you're going to be able to solve it nicely, because your calculator likes to do things in chunks. So if you put things in parentheses properly, it'll come out right. Okay, and if you do everything correctly, put it in correctly, you do wind up getting 840 over 1081. Okay, all of that could be put into your calculator. All right, on to number 7. Number 7 has 2 parts. We're going to simplify and evaluate. Now, this has already been expanded. This is the expansion. So there was a mistake on here. This should have been minus. Okay. So this is the expansion for cosine. So we're going to work backwards. That means that this looks like the expansion for cosine of A plus B. So that means that this must be A is here, and this must be B. So this is simplifying it. So I'm done simplifying. So now evaluating means get the answer. So the cosine of 135, that's your second quadrant. 135's reference angle is 45. So that means it's the same answer as 45, but in the second quadrant, cosine is negative. So it would be negative square root of 2 over 2. The next one is in radian form, but it's still the same thing. Look at the expansion. This best resembles sine of A plus B. Alright, so that means it's the sine of pi over 12 plus 5 pi over 12. That's simplified to 6 pi over 12. Well, 6 pi over 12 is actually pi over 2. We all know that pi over 2 around the unit circle is the same thing as 90. So the sine of 90, that's the second number in the quadrant, in the coordinate, so 0, 1. That means the sine of 90 is just 1. Okay? All right, number 8, prove and verify. Verify means that the left side should match the right side. So basically it's everything that we did for number 1 and 2, but instead we're just making sure that it matches the answer on the right hand side. So if we look here, we have secant squared plus 1 times secant squared minus 1. So we have to FOIL. Okay, my algebra 2s, we do a box method. You guys said you like regular FOIL, so we'll do that. So FOIL says first, which are these two. So secant times secant is secant squared. Outside, which is secant times negative 1, which is negative secant, inside, which is 1 times secant, or secant, and last, which is 1 times negative 1, which is negative 1, all over sine squared. Remember, our goal is that this equals secant squared. Well, if you look in the middle here, negative secant plus positive secant, they can cancel out because they are opposites. So we're left with secant squared minus 1. Now we're not going to cross multiply, we're not going to do any of that. All we're going to do is keep breaking down this side so it matches this side. So I know that this is an identity, okay? That's the identity of tangent squared. If you don't know that, look at the front of your review packet and you'll be able to see that identity. So now I'm going to break down tangent and break down sine to be a reciprocal. So I'm going to have sine squared over cosine squared. Change this fraction bar to multiplication and change that to 1 over sine. Now if you look, we have 2 sines squared, so they can cancel out. And we're left with 1 over cosine squared. Well, we do know that 1 over cosine squared is equal to secant squared. So we are correct. They are verified. The left side of my equation matches the right side. All right, the next one, we have sine cubed theta plus sine theta and cosine squared theta. So what we can do is we can see that both groups, this is a group and this is a group, both groups have a sine in common. So I can divide both groups by sine. When you divide by sine, that means you're factoring out sine and putting it on the outside. If I take one sine away from here, I'm left with sine squared. And these sines cancel out, and I'm left with just cosine squared. Well, if you look inside, this is an identity. Okay? Look on the front of your exam review packet, and you'll see that that is an identity. It's an identity of equal to, right, 1. So this whole thing becomes 1, and that sine that's on the outside stays there. Remember, our goal is that the left side matches the right side. So sine times 1 is sine. So they've been verified. And all you have to do to verify is make sure the left matches the right and put a little check mark. That's all. Alright, just so that you guys don't get confused, this is A and that's B. Alright, one more and video's done. Okay, so here we have to solve, and when you're solving, that's when you figure out what is x equal to on the unit circle. So I look here, it says 4 sine squared x minus 1. This is something that you have to factor. So when you have a square, chances are you're going to factor, and there's 4 different types of factoring, but I'll go over that in a second. So this is the first, this is what's called difference of 2 perfect squares. So I can take the square root of each term. So the square root of 4 sine squared is actually equal to 2 sine x. And I'm going to write that twice, because 2 times 2 is 4, and sine times sine is sine squared. The square root of 1 is 1, so I'm going to write that twice. 1 times 1 is 1. Now because there's a minus there, I'm going to separate each of these terms with a plus and minus. And now if I were to FOIL it out, 2 sine times 2 sine is 4 sine squared. 2 times negative 1 is negative 2 sine x. 2 times 1 is positive 2 sine x, so they cancel out. And then 1 times -1 is -1. So foiling it out checks my answer. So now I'm going to take each of these pieces and set them equal to 0. 2 sine x plus 1 equals 0. 2 sine x minus 1 equals 0. Minus 1 on both sides. Divide by 2. So I have sine x is equal to -1/2. On this side, add 1. Divide by 2. Sine x is equal to 1/2. So I have two different things that I need to look at. So sine x is equal to -1/2. Sine is negative in two places. It's negative in the third and fourth quadrant. Sine is equal to 1/2 at 30. So the reference angles, the angles that have a reference angle of 30 would be 210 and 330. Now you also need to know their radian measurement. So the radian measurement for 210 will be 7 pi over 6. And the radian measurement for 330 is 11 pi over 6. So you need to know how to do both. Now sine is positive in two areas, in the first and second quadrant, so that would be 30 and 150. So that would be pi over 6 and 5 pi over 6. So there are your answers for part A. All right, last but not least is part B. Part B is a regular two-step equation. You would solve it just in the same way that you would solve this question. -1 and then divide by 2. So cosine of x is equal to 1/2. Well, we know two areas where cosine is equal to 1/2. In the first quadrant and in the fourth quadrant. So that means x is going to be 60 degrees and 300 degrees. Because those are the two spots that cosine is equal to 1/2. So that means that it's pi over 3 and 5 pi over 3. All right, so that's your review sheet. That's basically, in a nutshell, everything that you need to know for tomorrow. Now I'm going to do the 4 different types of factoring real quick, just so that you can see what your expectation is for factoring. All right, the first type of factoring is called GCF factoring. And that's when you share a common term. So, for example, you would have like 8x plus 64. And if you had to factor that, they both can be divided by 8. So 8 goes on the outside, and the result after you divide goes on the inside. So you can do this with sine. So just because it says sine x as opposed to x doesn't mean that the factoring changes. It just looks different because it says sine there, but you still are going to do everything the same. So that's called GCF factoring. All right, the next type of factoring is A equals 1 factoring. And when I say A equals 1, I mean for this is the quadratic expression. So A would be this coefficient here. So when A equals 1, the example would be something like x squared minus 5x minus 50. Okay, that's an example. So to do this type of factoring, you're just going to see what adds up to -5, but also multiplies to -50. So you think about your factors of 50. Well, I know 25 times 2, that wouldn't work. 10 times 5, that might work if I make one of the answers negative so that I can get 5. So if I have 10 times 5 and I make 10 negative, I get negative 50. And if I add them with negative 10, I get negative 5. So those are my factors. So you go negative 10, positive 5, and then the x comes here, and that's how you factor. Now, if it was cosine, you still would do everything exactly the same way that you did there. You would wind up having two factors, cosine minus 10 and cosine plus 5. Still the same, nothing changes, except instead of having a x, you have a cosine. All right, the next type of factoring is a is greater than 1 factoring. And that is for your quadratic expression, where this value here would be greater than 1. We call this the Berry method. And you could just look up Berry method on YouTube and watch it. All right, so suppose you had this example. The first thing that you do with this is you multiply the first and last, always. And you only multiply first and last when there's a number in the front. So first and last is equal to 6. So I need two factors that multiply to 6 but still add to the middle. Okay, so when I think about 6, I think about 6 times 1. Well, 6 plus 1 won't give me 5, so that's not going to work. So maybe I'll try 3 times 2 is 6. 3 plus 2 will be 5, but I need it to be negative 5. So I think I can do negative 3 times negative 2, which will give me 6. Negative 3 plus negative 2 does give me negative 5. That works. So those are my two factors. The Berry method says just take this piece that's in the front without the square and input it in the front. So now you're left with one factor that can be reduced and one factor that must stay the same. This can be reduced and be divided by 3. So my final answer for factoring will be x minus 1 and 3x minus 2. The same thing can be applied to, trig. So if I made this 3 secant squared minus 5 secant plus 2, you can still do the same thing. These still can be divided by 3, and your final answer will be secant minus 1 and 3 secant minus 2. Now the only thing that's different between this and this is that you're going to have to set this equal to 0 and then find the things on the unit circle that will allow for you to get the final answer for x. That's the only difference. Okay, so you would have to set this equal to 0 and solve, and set that equal to 0 and solve. Okay, the last type of factoring is perfect square factoring. And we call this the difference of two perfect squares. Okay, so it's usually like ax squared minus by squared, something like that. So usually you'll get something like 4x squared minus 9. These are both perfect squares. So if you take the square root of 4x squared, you get 2x times 2x. The square root of 9 is 3. So in order to make it a difference, you have to have two different signs in the middle, a plus and a minus. And that's it. That's all you would have to do to factor. So suppose we put a tangent with that. it doesn't change anything that you do. The square root of 4 is 2. The square root of tangent squared is just tangent. And the square root of 9 is 3. So you would just put inside your parentheses 2 tangent x plus 3, 2 tangent x minus 3. And then from there you would just split them up, solve them by setting them equal to 0 and getting your answer from the unit circle. All right, well, I hope that helped. You guys said that you're going to go back and forth in the video, stop it, play it, stop it, play it. So hopefully this will help. Please make sure that you do go for the review sessions tomorrow. Tomorrow we'll be in room 282, which is Ms. Croker's room after school at 2:15 or 2:20. I will be doing Wednesday, and Mr. Mahaney will be doing Thursday, and he's in room 314. All right, good luck everybody on tomorrow's test, and you will have the most updated completed grades for everything hopefully by Thursday, so you know where you stand before you take the final. Okay,